We've got 4 theorems for today. It's all parts of similar triangles. So parts of the triangle meaning like different parts made within a triangle. So everything for these first 3 are starting with two triangles that are similar. If you have 2 triangles that are similar, that has to be written in there somewhere, or it has to say, like, give you enough information to know the triangles are similar. 3 parts also fit in with your proportion, because we know all the sides are proportional or similar triangles. We know the perimeters are all proportional as well. The different parts of a triangle could also be proportional, included in the proportion. It's the altitudes. So we have our 2 triangles, which means our altitudes also fit in with that same proportion as the sides and the perimeter. It's also 2 triangles that are similar. The angle bisectors are also fitting in with the proportion. So there are your 2 angle bisectors, so showing that marking that it's bisecting the angle. And it would be any of the angle bisectors, because you can create an angle bisector out of any of the vertices. So as long as you have that marking. And the third part of a triangle, and you have 2 similar triangles, the medians are also proportional. Medians, remember, go from a vertex to that opposite side, splitting that side into 2 equal parts. Okay. Again, it's talking about this part that is proportional. The actual like bisector or median or altitude, the actual line itself, that fits in proportion. So that's our 3 parts of a triangle when you have 2 triangles. The 4th theorem for today is if you have 1 triangle. If you have 1 triangle and we're focused on the angle bisector. So if you have multiple triangles, the angle bisectors are proportional. But if you just have a single triangle, there is 1 triangle that we have, and it is split with that angle bisector. That angle bisector creates proportional parts within the triangle as well. I'm going to relabel these as A, B, and then C, D, just because I like seeing those instead of KM and LN and all that. But what this is saying for that proportional part is that A over C is proportional to B over C. The other way you could think of it is A over B and then C over D. It still creates that B times C and A times D for your proportion, like when you cross multiply, it still is the same for this part. The only reason that you would like care about these 2 different ways to write it, depending on proportions, I don't know if y'all started it. Do y'all ever solve proportions where you think about like, oh, what fraction do I want to set up? That way I could possibly simplify it. Does that ever cross your head? Cross your mind? Okay. Well, because we talked about how you can set up proportions different ways, right? You just need the same cross section, like the same means and extremes, like cross multiplying. So I kind of switch it. That's where this is going to come into like helpful. I switch it based off of like the numbers. Like if I see some numbers where I can reduce something, so instead of working with like crazy numbers, I can reduce a fraction and make it simpler to solve. So just an idea. Okay. So if we look at this one, we're solving for x. Our 2 triangles are congruent. Wonderful. What's that special segment marked on here?
Altitude.
Altitude. All right, so altitudes, medians, and angle bisectors. Those 3 have the same proportion if we have similar triangles. So we get to write that 7x over 9x, and then 8x minus 1 over 10x plus 1. Before you solve it, simplify it. That way we don't have to worry about solving a quadratic. Instead, we have 70x plus 7 equals 72x minus 9.
If you could cancel out both x's on the right, how come you can't cancel out both x's on
The plus sign and the minus sign. Whenever you're canceling something out, when it's like a binomial or trinomial, like multiple terms, everything has to cross out everywhere. Like you can't just simplify 10x over like the 8 and 10x. The plus sign screws it up. So in general, if you ever have something in a proportion, I generally don't try and simplify anything over here with that section. Even if you potentially could sometimes, I generally don't, because like sometimes you can, sometimes you can't. And unless you are like down pat, you know exactly the reason when and where, like when and why. Don't worry about it. I'll calculate. X is 8. We okay with that? All right. That is actually our only problem that covers the first 3 theorems that we went over. Just because if I gave you 2 more triangles and I just gave you a median, it's the same problem. So the rest of our problems are going to focus on that 4th theorem that we just went over, where it's a single triangle and we have an angle bisector. That's the rest of our problem for today. Just kidding. We have 1 more. My bad, I forgot. Okay, so we do have 1 more. This is the last one that involves here. What is being shown on this one? Median, yeah. Okay, so medians fall into that same category. So it creates these proportional parts. We can have 8 over 12, and then 5 over x. We're going to simplify 8 over 12 to be 3 over 4. Makes your life a little bit easier. Just kidding, 2 over 3, not 3 over 4. Divided by 4, so that's 1. 2 over 3. Which makes x correct. Alright. That is now our last one with those theorems. So we're not doing one where it's comparing the 2 angle bisectors. We got a median, we got an altitude. Okay. The rest of ours is going off of that 4th theorem, which is the angle, or the triangle angle bisector. For this one, the setup. It's marked with an angle bisector, so that means the little parts that are created from the angle bisector are proportional. We can put this over that. I like that option because you maybe can simplify with those numbers. If I have 7 over 21, what does the other one have to be? Correct. But 7 over 21 is really 1/3. So what's our n value? 15. Wonderful. Okay. I'll do that next one. All right. For the next one, so the next one's a little bit different. It's showing an angle bisector. Our proportion that we set up is with what's created, those 2 small segments created from the angle bisector. So we can write, we have this one as x, but how can we write that AD? Good. 40 minus x. And now from here, before I was writing it as like x over 32 and then 40 minus x over 24, which is fine. You can write it like that. But if those numbers are written over each other, we would be able to reduce it. Right, so then we would write the other one as 40 minus x over x. It would create the same cross product as the other way to set it up. It just makes this easier, because that would be 3 over 4. 3x, and then 160 minus 4x. 160 doesn't divide by 7, so we're just going to put it. You okay with that? Alright. So then, y'all do the last one. Wonderful. Okay, that's it. For our notes, for the stuff y'all were